Welcome back, folks. This is part 3 in our robot arm build series. So in our last video you saw me assembling this bit of the arm and wiring up some servos to test it. So you saw in that video that I used this little potentiometer just as a little test control input to move around the arm. Since then I've got some parts delivered, which are these little guys, these are PlayStation 2 replica thumbsticks, which I didn't know you could just buy these on their own, but they're brilliant. They have the thumbstick and they've got a little board connected to them, and they have their pins all labeled for the outputs, which is great. I also didn't realize that they're just really simple, just like analog linear potentiometers. So each controller, each thumbstick has 2 of them for the X and the Y axis, and then it also has a little push button switch which activates when you press down on it. So what I've done here is I've taken these and I've wired them in to the 2 axes that we have of the arm so far assembled, and I managed to get them running pretty smoothly, which is pretty cool. So I can move around my thumbstick and I can get the arm to move around, which is pretty cool. It tends to move pretty well. I let go of it and it nice and slowly comes back to its position. So yeah, I'm pretty happy with that. That was a nice little find, and they work really surprisingly well. And I think I have a little slip there in the actuator because that's just moved out of position. Yeah, it should be more like that. So I need to tighten down some screws there. So anyway, first part of this video, what we're doing today. So in this video, we're going to talk about the grabber, the end effector. But the first thing we're going to do is we're going to tackle this horrible mess of wiring. So I'm going to make some proto board stuff. I'm going to solder up all the connections, make that a bit nicer, and I'm going to run wires nicely down properly, and I'm going to come up with a way of mounting these as well. So probably we'll make a control box. It'll just have these on top. There'll be probably 2 of these to control all the various axes and functions that the arm's going to have. So we're going to do that. Okay, so the electronics are tidied up quite nicely. So the next thing I need to do is make a box to put them in. Let's see if this works. That didn't seem quite right. Hold on, let me try again. That's more like it. Okay, cheesy bits aside, I made a box. If you follow this channel for a bit, you'll know how much I love making boxes. So I have electronics box with a lid. Have all my electronics tidied up. So let's install them into their lid, into their box. Okay, so there's our little electronics enclosure finished. It's pretty neat if you ask me. Have my thumbsticks mounted on top, so you can press the buttons, you can move them around. Got our power switch on the side here, along with our power socket. So yeah, let's plug it in and hope that in all of that I didn't mess something up. Also, I know these little screws are not ideal. I thought I had a box of tiny little self-tappers that I wanted to use. Usually I have no problem putting wood screws into 3D printed parts, but I wanted to use some small little self-tappers. It'd be neater on those electronics boards, but couldn't find them. So don't at me, but this is what I used. Alright, let's plug it in. See what happens. Okay. I was terrified of plugging this thing in. Ooh. Okay, we're live. Okay, so that's the on position. I should probably label that, and also I probably should put a power light on it. That's an improvement. Let's see. Oh, okay, that one's not the wired one. This one. Oh, there we go. We have movement. Why is that not doing anything? Is that one not connected or something? Up and down axis, so that is meant to be doing something and it's not. Anyway, I can figure that out. I don't know why that's not working. I thought I had it all wired and coded up. So yeah, I can open that up and check that out, figure out why that's not working. But for now, this bit works. So that's pretty cool. It's quite a neat little box now to have all the electronics stored in. One cable goes in, a pile of cables will come out. The next thing I want to do is I want to just like route all these cables properly on the arm, tidy them all up, and I'll probably put them all in one piece of trunking that'll come out to like here, and then you'll split off to the normal wires. So you'll just have power cable comes in, trunk of cables goes out, and that'll be the whole thing for the arm. So yeah, once I make all those cables and do some neatening up there, I might wait actually because I have to do the end effector for the arm. So that's the next big piece I'm going to do. So you guys can watch that part next. Quick note, I figured out why that wasn't working. This patch cable that I plugged in with the little pins in between, plugged it in backwards. So if there was no signal going to this, it does actually move. And it moves in with the right axis that I thought it would. Problem solved. So here we have our completed end effector. I normally show you the assembly of a lot of these parts when I do them, but the assembly for this didn't go very well, and I'm afraid to take it apart again in case I can't get it back together in a working state. But it does work. The driven side of the arm moves, and the gears on the arms mesh together to have them move together. This arm has a little bit more movement in it than I'd like. I think this is. I think I am going to redesign this at some point. I don't really like it that much now that I'm dealing with it. I have this habit when I'm designing some things like this where I kind of design the things too small, as in like, you know, the physical dimensions of the things are a little bit smaller than they need to be really, and then it just makes 3D printing the parts hard, manufacturing the hard, assembly hard. You know, you've got little fiddly things that are too small to handle the load that they're going to be put under, things like that, which just, you know, don't really work. There was meant to be a plastic retaining pin in here, which of course was just far too fragile when it was printed out to actually work the way I wanted it to. But this works for now, so I'm going to run with this. It'll allow me to allowed me to test everything with the servo in place, and it does grab. So yeah, it's okay. Okay, so I'm gonna put it on the arm, and then we're gonna have a mechanically finished arm, which is pretty cool. Okay, so it's together, but we have a slight problem. I didn't get my clearances just right up here. So the radii on these little parts, they bind, so it doesn't really move smoothly, which is kind of a pain. I thought I had matched up with like the dimensions down here, but it seems I hadn't. Obviously just made it just a little bit too snug, so that's annoying. I mean, you can force them, but obviously you don't want to do that. What I'll probably do is I will probably take the arm, the end effector off, and I'll probably just file down the edges, the outside of that, to make it a little bit smoother, so that it can go together better. But effectively, that's it. Also, again, with my designing things too small and in the wrong order of operations, this little jaws, I can't get a screwdriver in there to turn that. So anyway, it is mechanically finished, so I am gonna probably address some of those issues, and I'm gonna wire up the rest of the servos, and then we'll give the whole arm with all of its axes a little bit of a test. Okay, we've got a good milestone for this project. We have the whole robot arm pretty much assembled mechanically. It's all pretty much there for now. We have everything wired up, we have the controls in, and we can run all of the axes now, which is pretty cool. So if I turn it on, always nervous of that startup. It's not going to do something crazy, but see, we can open and close our end effector, which is kind of cool. It's not the smoothest, but it does work. We can move side to side, which is cool. Now this one always has me nervous when I move it that it won't. Yeah, it's going alright. Always afraid that it's just gonna fly around. And this one, that's working. It's slipping a little bit, but it is working. So, I mean, none of this sounds great, but it does all work. So this, I think, is a good baseline to start from. It's a good place to start for the rest of what I need to do on this. So I figured out there's a lot of things going on with this that I'm not hugely happy with. This coupling mechanism that I've come up with here, it's not really very robust. Like these, the way I have it, that these two grub screws that grab onto the shaft, it's not robust enough. So when you have it extended out with enough weight on it, the whole arm will have a tendency to just rotate. The shaft will have a tendency to just rotate inside those grub screws, which means that they don't actually do anything. So the whole arm could just flop when it's extended under enough weight. So that's something I want to try and address, figure out if I can come up with a better means for that coupling together. The other thing as well is that you might not notice it, but when I was moving around the thumbsticks here to get all the axes moving, I basically have wired directly the angles of each axis to one of these directions on this thumbstick, which isn't ideal because that means that I'm manually setting it. Whereas what I'd really like to do is I'd like to have, say, one thumbstick just be, the X and Y position of the end effector, and that it would work out all of the angles for how to get there on its own. And then I could have another one just for rotation, which is pretty simple. So I think the next thing I'm going to do is, I think I'm going to go and I'm going to figure out maybe how to make these connections a little bit better, a little bit mechanically, a little bit more sound, so that it doesn't have a tendency to slip as much. There's also a problem that there's a bit of backlash in these servos, so that once it has a little bit of movement, there is some slop where it can kind of force itself through, which doesn't help. Yeah, so I think I'm gonna see if I can figure out some better mechanical connections there. And once that's done, I think the next thing I'm gonna do is, which I'll probably show in the next video, is I'm gonna figure out a nice XY coordinate system that I can map to this. Hopefully using some sort of like inverse kinematic model or something like that. So yeah, I think that's about it for this video. I'm pretty happy with this thing, even if it's not a little bit janky. It does work more or less the way I thought it would. I kind of didn't expect that it would be much more stable than it is. So yeah, hope you've enjoyed. If you like watching this video, don't forget to like, subscribe to the channel, share with your friends, and if you'd like to help support the work that I'm doing, you can find a link in the description to my Patreon. I think that's it for now, guys. See you next time, and thanks for watching.